A container in the shape of a cube has dimensions 4 by 4 by 4. The container is sitting on a horizontal table on one of its faces and is filled with water to the depth of 2 centimeters. In centimeters cubed, what is the volume of the water in the container? Well, let's draw a cube. And let's see, that's a 4 by 4. So if it's sitting to a depth of 2, that's approximately here. So this is all going to be, I guess, I don't have to make the diagram too confusing, but you guys understand. So the volume of the water, this is 4, and that's 2. So the volume will be 4 times 4 times 2, which is 32. A group of students were asked to choose their favorite of the 3 colors, red, green, and blue. Unfortunately, some of the results of the survey were lost. All of the remaining data are expressed in both the pie graph and the bar graph shown below. What is the total number of students that were surveyed? So it looks to me like the red, in terms of a percentage, was 100 minus 45 minus 35, which is 20%. So the red represents 20%. So if 20% is the equivalent of 8, which is shown here, then if you multiply both sides by 5, 100% would be equivalent to 40. And what that means is that there was a total of 40 students in the survey. So 40 is the answer. In the diagram, ABDE is a square and triangle BCD is equilateral. What is the measure of angle ECB? Okay, I'll blow this up just a little bit, and let's see what I can do here. Well, the square, obviously all 4 sides are the same, and if that's equilateral, then that means that's the same as that. So that means that this CDE, that triangle, is isosceles. So therefore, this angle will be the same as that angle. So let me just call those angles X, X, and X. And then this is a right angle, since that is a square, and that's 60 degrees, since that is the angles of an equilateral triangle. So in that same triangle, the angles are 90, 60, X, and X. And that, as you know, will always equal 180. So that means that 2x is equal to 30, x is equal to 15. Okay, what are they asking us? We were asked to measure something. ECB, right here. Okay, so ECB is where? This angle right here. Okay, well that shouldn't be a problem, since from here to here that angle is 60, and that really is our ECB plus our x, correct? So that basically means that since x is 15, 60 minus 15 will be ECB, and that is 45 degrees. The positive integers a and b satisfy 2a is less than b. The sum a over 4 plus b over 2 is greater than 27 and less than 28. What is the greatest possible value of a? All right, so we have 2a is less than b, and then a over 4 plus b over 2, that is greater than 27 and less than 28. Okay, and that's it. That's all we're given. So let's get rid of this fraction here. First, multiply top and bottom by 2. That'll give me a plus 2b over 4. And then I will multiply everything by 4 to get rid of that fraction. And when I do, I think I'll get 112, a plus 2b. And on this side, I get 108. Yeah, 108. Okay, where do I go from here? Interesting. Well, let's go with the only piece of information we have other than this. If 2a is less than b, if I'm trying to get a 2b, so multiply both sides by 2, so 2b is less than 4a, correct? And we are now adding an a, so let's add an a to both sides. And therefore, this a plus 2b is really greater than 5a, correct? Yeah. A plus 2b is greater than 5a. Okay, hopefully I've done this right so far. So that, if you go back to here, that means that 112, which is greater than a plus 2b, but a plus 2b is greater than 5a, like that. See, I'm just making that substitution there. And I think that will help me. Yeah, I'm pretty sure that that will at least let me get an A, and then I can see if that A is correct or not. So that means that 112 is greater than 5A, and therefore that A, if I divide through by 5, I get 22.4. So A is less than 22.4, so let's start with 22, and then let's go from there. So because we're trying to get the greatest possible value of A, right? Okay, so let's try A equals 22, and instead of saying, okay, we've concluded that that's the largest, we have to first verify that this is actually going to be, that's going to hold true. So how do I verify it? I have to plug it back in, right? Yeah, I have to plug it back in. Okay, so I have to plug it back into this guy. So if A is 22, this is 28 greater than 22 over 4 plus B over 2. It's just basically this one. I'm just writing it again. So this is 28 is greater than 5.5 plus B over 2, greater than 27. Then B over 2, subtract 5.5 from each side, and you get 21.5 and 22.5. Multiply through by 2, and we get B is between 45 and 43. So B must be 44. And then we have to see if this holds up with our values. 2A, is it less than B? Well, 2A would be 2 times 22, and B is 44. 44 is less than 44. Okay, so this is false. 44 is not less than 44. It's equal to. So that basically means that this A equals 22 is not valid. Okay, no problem. Since A is less than 22.4, let's try the next one, which would be A equals 21. And let's see if that holds up in our conditions. Okay, so same thing. Go back to the beginning. So we have 28 is greater than, it's this equation up here. So if A is 21, that's going to be 21 over 4 plus B over 2 is greater than 27. So that's 28 is greater than 5.25 plus B over 2 is greater than 27. And therefore, B over 2, subtract 5.25 from both sides, so 22.75 greater than 21.75, that kind of thing. Then multiply through by 2, so B would be 45.5, 43.5, and therefore B is going to be 44. Isn't that the same as before? Yeah. Oh, but at least A is different this time. Okay, so now let's see if this condition holds. Is 2A less than B? Well, 2A is 2 times 21, and B is 44, and 42 is indeed less than 44. So therefore, this value of A is the greatest possible value of A that satisfies the conditions in the question. Lakshmi creates a table with 95 rows and 7 columns. She places a positive integer in each of the 95 times 7, which is 665 cells according to the following rules. Every integer in the first column is 5. The cells in the second column contain the consecutive integers from 5 through 99 in order, with 5 at the top, 99 at the bottom. Every integer in the remaining columns is equal to the sum of the integers in the 2 cells directly to its left in the same row. The first 3 rows of the table are shown. How many different two-digit integers are in exactly 5 of the cells in the table? All right. So I'm assuming you guys understand all that. So what I'm going to do is I'm going to extend this table just a little bit, not by a lot. Well, the first 3 rows are done, but first let's label this. I'm going to call this C1, like for column 1. Let's see here, column 2, column 3, column 4, 5, 6, and 7. Okay, so they put in the first 3 rows. So I will try to fill in a few more based on their rules. So let's see here. Actually, let me just extend it down here. How many should I put? I'll just do. Let's see if I can just do 2 more rows. So this was row 1. This is row 2. This is row 3, and I'm putting in row 4 and row 5 basically. All right, let's see. Let's see what happens. Okay, well, this one is easy. These are all 5, so that's just going to be 5, 5, and so on. 5. I don't know. Let me see if I need to add a row 6. So that's pretty straightforward. And then the next one is just consecutive integers. So 5, 6, 7. So that's going to be 8, 9, 10. That's pretty straightforward. And then the next one goes up by 1. But let's see here. This 10 up here was obtained by adding the previous 2, 5 plus 5. This 11 was obtained by adding the previous 2, 5 plus 6, and so on. But it seems like it's going up by 1. So that means if that was 10, 11, 12, this is going to be 13, 14, 15, like that. Similarly, this 15 was obtained by adding the previous 2 terms, 5 and 10. This 17 was obtained by adding the previous 2 terms, 6 and 11. But it seems like it goes up by 2 every time. So it's 15, 17, 19. So I'm pretty confident it's 21, 23, 25. And similarly, the next column looks like it goes up by 3 every time. So that's going to be 34, 37, 40. The next column looks like it goes up by 5 every time. So 55, 60, 65. And the last column looks like it goes up by 8 every time. So it's going to be 89, 97, and what's the next one? 105, and so on, right? And then eventually, you'll get to the very last row. And the very last row, what will it be? 95 rows, right? Is it 95 rows? Yeah, 95 rows. So that will be row 95. And these are all 5s. And I guess it will be 95 rows. This will be a 99, and so on. I mean, and I think this will be a 104. Yeah. Okay, and you guys get the point. I just wanted to fill in to kind of illustrate the rules a little bit, these rules here. And I'm sure you can do that on your own. Okay, so then what is the question here? The question is, we want to look at all of these and then see which numbers appear exactly 5 times. So how many 2-digit integers are in exactly 5 of the cells? So we are only interested in 2-digit numbers. So the numbers that are 10, 11, all the way till 99. Those are the only numbers we care about. And these numbers have to appear in 5 of these cells. So there's 7 times 95, which is 665 cells, right? They even tell you that in the question. So for example, let's just make something up. Let's say the number 27 appeared in 5 cells. That would be a number that we are interested in. That's basically what that sentence is asking. So we have to figure out how many times does each number appear, and then look at the ones that appeared 5 times. Okay, so here we go. How are we going to do that? All right. All right. Well, C1 is all. Let me just take it one step at a time. C1 is all 5s. So C1, we are only interested in 2-digit numbers. So C1 basically is irrelevant to our conversation. C2, it does start with a 5 up here, but eventually does get to a 10. So C2 looks like it's all the numbers from 10 to 99 will appear once. So let me put that in there once. Okay. C2, again, it starts with the 10 and goes all the way up to 104, but we don't want 104 because 104 is a 3-digit number. But we are just interested in the 2 digits. So again, 10 to 99 will be there. And therefore, cumulatively, these numbers look like they appear twice. Like the 10 appears, for example, here in that cell, but it also appears here. And similarly, the 11 will appear here, but then the 11 also appears here. So every number from 10 to 10 until 99 will appear twice. Once in a cell in column 2 and once in a cell in column 3. All right, moving along to C4. C4 is 15, 17, 19, all the way till 99. Okay, so that means those numbers appear 3 times. So let me put 3 times there. Just those numbers, the 15, the 17, the 19, all the way to 99. You got it? Because they would appear once in column 2, once in column 3, and once in column 4. All right, so now we go to column 5. These numbers are 25, 28, 31, all the way up till 97, if you keep adding 3. So those numbers will appear 4 times. Now, I would like to make a list of those numbers, and because I'd like to keep everything on the same screen, let me just put it here. So which column was this? This was column 5, right? So C5, let me just list them because I don't think there's that many. So 25, 28, 20, hold on here. But when I actually make this list, I'm only interested in numbers that will also appear here in C4, because I'm trying to get numbers that will appear in all of them in order to get up to 5 cells. So the only numbers that are in C4 are, looks to me like odd numbers. So I'm only going to include the odd numbers that appear in C5. So 25, but not 28, but 31. You see what I'm saying? And then 37, 43, and then 49, 55, 61, 67, 73, 79, 85, 91, and 97. Yeah. These numbers appear 5 times. Yeah. Because all these numbers appear in C2, C3, C4, since they're odd, and in C5. Well, sorry, 4 times is what 4 times, right? Yeah, 4 times. Sorry, that should have been a 4. I'm getting a little too ahead of myself. Yeah, 4 times. Yeah. So 4 times. Yeah, because they would appear in C2, C3, C4, C5. Okay, so we're getting close to that magic number, I guess. Now we have to go to C6. Okay, so C6. What is C6? C6 is here. I actually didn't even list it yet. It's going up by 5 every time. So basically it's 40, 45, 50, 55, 60, 65, all the way till 95, obviously. 40, 45, all the way till 95. Now, we want numbers to appear in every cell. Now, is there anything that appears in C5 that would appear in C6? I think this one and this one. Yeah. The 55 and the 85 are the only ones that would appear in both of those. So those 2 numbers appear 5 times. So there we go. I hope that made sense. So these numbers appear in C2, C3, C4, C5, and C6. 5 times, which is exactly what the question asked for. Okay, but we are not done because we still haven't talked about C7. Don't think that you're done, because we still got to talk about C7, right? Now, what is C7? C7 looks like it starts at 65, then goes up by 8, right? So 73, 81, 89, and then 97. Okay, so there's only 5 numbers there, so that's actually good. Now, do any of these 5 numbers appear in 4 additional cells? Now, this one has all of them. This one has all of them. This one has all the odd ones, and all of these in C7 are odd, correct? Yeah. So now, let's see here. How about C5? C5 is here, this guy. Do any of these appear in C5? 65 does not. 73 does. Okay, that's very helpful. 73 does in C5. Does 81 no, and 89 no, 97 does. Hold on. Yeah. Yeah, 73 and 97, they do. 73 and 97. Okay, so 73 and 97, I got them in 5. Because it'd be in C5, C2, C3, C4, and C7. Okay, so there's one more. So we got this 73. We got this 97. Any of these other ones appear in all 5. I think maybe the 65 would. Because 65 would be in this one, this one, this one, this one, and this one. Yeah. So I think I got it. 65, 73, 81, 89, 97. And of those, I've got 97, 73, and 65. So let me make a summary here of the numbers that I've got: 55, 85, 73, 97, and 65. And it appears, so let me write that in here, appears in cells, in columns. So 55 appeared in which columns? Column 2, 3, 4, 5, and 6, correct? 85 appeared in columns 2, 3, 4, 5, and 6. Number 73 appeared in columns 2, 3, 4, 5, and 7. 97 also 2, 3, 4, 5, and 7. And 65 appeared in columns 2, 3, 4, 6, and 7. There we go. That is the list of the numbers that appear in 5 cells. Eight points are equally spaced around the circumference of a circle, and pairs of points are connected by 4 diameters as shown. The 8 points are to be labeled randomly using the integers from 1 to 8 exactly once each. What is the probability that at least one of the 4 diameters has a multiple of 3 at one of its ends and a multiple of 2 at the other end? All right, so if you have 2 and one has to be a multiple of 3, so 3 times something, and one has to be a multiple of 2, so 2 times something, and our numbers are 1 through 8. 1, 2, 3, 4, 5, 6, 7, 8. So the multiples of 3 in that list are just 3, 6. The multiples of 2 are 2, 4, 6, and 8. So that's it. And then what are we trying to figure out here? A probability. Okay. So the probability of meeting this condition is what we're trying to figure out. But I think it's easier if we figure out the probability of not meeting the condition. And then we can just subtract that from 1. So if that probability is A, the probability of meeting the condition will be 1 minus A. 1 minus A. So not meeting the condition, let's see here. Let's see. Not meeting the condition. So let me put it over here. Not meeting the condition. And the condition is that one side has to have a multiple of 3 and the other side has a multiple of 2. So for example, if this is, let's say, like if this is a 3, one side, the other side has to have a 2, something like that, or a 6 and a 6, or a 3 and an 8, that kind of thing. Not meeting the condition. Okay, what are some scenarios where you would not meet the condition? One side has a 3, and the other side does not have a multiple of 2. So the numbers that are not a multiple of 2 from our original list are 1, 3, and 7. Correct? Sorry, 1, 5, and 7. Because the 3 has already been counted. Sorry about that. Okay, so that's an example of something that does not meet the condition. Another is if you had a 6 and then you had something on the other end that's not a multiple of 2. So again, the 1, 5, 7 scenario. Either 1 or a 5 or a 7. So now let's talk about these. For each of these, what is the number of cases? Well, for the 3, let's see here. Be easier if I just demonstrate it on the wheel or circle, whatever this is. So let's say I put the 3 here, right? I've got 8 possible places to put the 3. I just put it there, but there's 8 places. So I've got 8 possibilities. I'll just put it in a bracket to put the 3. And then on the other end, I've got to put either a 1 or a 5 or a 7, correct? So I've got 3 choices. Either I put a 1 here, or I put a 5 here, or I put a 7. So I've got 3 choices. So I've got 3 choices for that end. Got it? And then now the 6, this point and this point have already been occupied. So I've only got 6 points left for the 6. Any of the 6 remaining. So let's say I put the 6 wherever you want to put it. Let's say you put it here. And on the other end, I've got a choice. Either I put a 1, a 5, or a 7. But remember, one of these has already been chosen. Let's say I put the 1 here. That means I've only got the 5 or the 7. So I only got 2 choices remaining for that end. You got it? So hopefully that made sense. And then for the remaining numbers, which in our case would be, let's see, the 1, 5, and 7, that's been used. And the 3, well, actually, let me backtrack here. Let me make a decision as to what I'm using. I used a 1 here, so let me use a 5 there, like that. So that means I've used the 3, the 6, the 1, and the 5. So I got 4 numbers remaining, and I can place them any way I want. For this 2 here, I have 1, 2, 3, 4 possible places to put it. And then for the 4, I've got 3 remaining places. For the 7, I have 2 remaining places, and for the 8, I have 1 remaining place. So if you multiply all the brackets, 8, 3, 6, 2, 4, 3, 2, 1, it would be 8 times 3 times 6 times 2 times 4 times 3 times 2 times 1. Okay, so that's the probability. Well, actually, that's not the probability. That's the number of possibilities. So what we have to do to get a probability is put it over the total. This is the number of possibilities that do not meet our condition. The total goes in the denominator, and the total is just 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Like we have 8 possibilities for the first number, which whatever that first number is, 1, let's say. We have a remaining 7 possibilities for the remaining number, the next number, and then a remaining 6 possibilities for the next number, and so on. That's just the total without any conditions. So this is the probability, and when you reduce all this to lowest terms, this becomes 6 over 35. Now remember, it's right here. What we just figured out was A. What we want is the probability of meeting the conditions. The probability of meeting the condition would be 1 minus A, which would be 1 minus 6 over 35, and that is 29 over 35. And 29 over 35 is the answer to this question.